All right, so the rest of this chapter. So the remainder theorem. If a polynomial is divided by x minus k, the remainder is f of k. So pick a polynomial, Kelly. X cubed, make it long.
7x.
Minus 7x.
Plus 4.
Plus 4. Okay, so if we divide that, pick, what do you want to divide it by? Let's make it, let me make one even, that way we don't have a remainder. Well, I don't want, let's make it simple, so let's do, x squared plus 4, 2x plus 4, okay? That way I know I can divide it by what? X plus 2. Okay, so let's put, I do that because we can put it in your numbers. So if we take f of k, what's k? Be careful.
X plus 2.
What's that?
No, minus 2.
Minus 2. So if I put minus 2 into my function, put a minus 2 in here, what do I get? I just evaluate here, minus 2. Minus 2 squared.
0.
I'm just substituting in a minus 2 right
Oh,
now.
okay.
0. No, wrong.
It's 0,
Oh,
right?
yes. 0.
Weird things are happening to me. Okay, so if I have a polynomial, I know my remainder is whatever I put in there. So if I have a minus 2, that's where it's going to cross the x-axis. Where's the, this is from the previous one. So f of minus 2. This is the one we did. Here's the plus 2. So if I put minus 2 into the one that we did on Friday, what am I going to get if I put a minus 2 into here?
Ooh. Yeah.
Okay. $900?
I got negative 44.
If I put negative 2 in for x?
This is negative 10.
Negative 2.
No. Negative 2 times negative 2 makes negative 2. Negative 8.
Wow.
Right?
Multiply by 5
It's all right.
first.
No,
and
it's
then
all
you
right.
multiply by 5.
Order of operations, right? You do your exponent before you multiply.
Negative 44.
Wait till she gets it. You see it's negative 44?
Yes, I figured it out.
That's all the remainder theorem's telling you. That's all the remainder theories.
Listen.
No.
But
That's all the remainder theorem is telling you is that when you put in your remainder and you plug it into your function, it'll evaluate it that way. That's all that remainder theorem is telling you. And they put it in those crazy. They like to use these, and this will confuse you when they put them into these letters, right? But whenever you put in whatever your k is back into your function, it'll evaluate it at that point.
Sure. Let's go with that.
The factor theorem. A polynomial f of x has a factor x minus k if and only if f of k equals 0. So in the last problem, you put in your negative 2 and it gave you negative 44. That tells you that there's a remainder, okay? That's how you knew the remainder from the previous one. However, if you put that in and evaluate it and you get a 0, then that tells you it goes in evenly. There is no remainder, in other words, okay? So use synthetic division to find each value of the function of x cubed minus 28x minus 48. Okay? So all you're doing is, for these 4 different numbers, you're going to substitute those numbers in and see if you get a 0. If so, you'll find a factor. So do those. So in other words, we got what? Negative 4 cubed minus 28 times negative 4 minus 48. So just evaluate that.
Ooh.
Did you get it?
Possibly.
What do you got? Just shout out when you know it.
What are we looking for? Wait, are we trying?
F of -4. Just what's it evaluate out to?
Wait. What do you mean by that?
I mean, if you put a -4 in, which I did here, and I do
Oh.
my arithmetic,
I
and
thought
I
we
plug
were-
it in,
wait,
what's
why
my
is it-
answer going to be?
Then why is it asking us to do synthetic division?
You'll see in a second.
What do you?
You'll see in a second. Just
But I
evaluate
just-
it first.
Is it 32?
I don't think so.
0.
It's 0. Right?
Yeah, because I just did the synthetic division and I got no remainder. So it's yeah.
Okay.
I don't like this.
Now, all this is taking a -4.
Yes, I know, but I don't know what I'm doing wrong. I'll figure it out.
Well, what's -4 cubed?
I don't know, that's the problem.
Negative 64.
-64. 4 times 4 is 16 times 4 is 64. -64
That one's big.
minus 20. That's a big number. Well, 25 times 4 is 100. So 3 times 4 is 12. 112, right?
What?
You're multiplying -4 by 28, right? 4 times 25, you know, that's 100. There's 3 left over. 3 times 4 is 12. 144. 112.
Oh!
That's all I'm saying. You got all confused when I said 28 times 4. So do you see how that's 0? All right, now
Yeah.
keep going. There's 3 more.
No.
Keep going there. So evaluate each of those and tell me what you're getting.
Oh, we're doing some more.
Yeah,
Yes.
there's 4 of them to do.
Let's do math. Don't worry, I have
What's that?
My calculator.
Didn't charge it.
Oh, Ben, I got your calculator.
Really?
Yeah, I forgot. They mailed it today, and it's here plugged in.
Oh, they gave the replacement one?
Yeah, they gave him the replacement. They sent the wrong one, and then here's
Oh, and Mr.
here's
Steak.
yours.
Minus 2 is 0.
Yes, it
Yeah,
is.
I got that one.
Okay, keep going. Good.
Getting smarter.
0.
Did I get -7?
For the third one?
Yeah.
Why did you?
Is that not right?
It's not right, no.
Yeah, I
It's
I don't know why you didn't know. You just used a calculator?
did. Yeah.
Okay. 3 cubed
Yeah, 3 cubed. Minus 28.
times 3
Oh,
That's 3. Minus 84.
minus 48. Is that what they put 84 in?
I don't know.
actually, I just got negative 105.
Yeah.
That's what I got.
Oh!
Jeez.
I'm like,
Let's not get my friends involved.
can we do this?
Okay. Huh?
Can we do this more often? I feel like it.
Just shoot this to show you how it works. All right. So then the last one is 6.
It's 0.
Is that what you got, Ben?
Yep.
So what does all that tell you?
This isn't stupid.
No, what does it tell you? This
Only
is
f
our
of
function.
3 has a remainder.
What's that?
Only f of 3 has a remainder.
All right, but for the factor theorem, a polynomial f of x has a factor x minus k if and only if f of k equals 0.
So there's no x minus k.
For these 3, they're 0, right?
Yeah.
So what does that tell you about this function?
It has a factor x minus k.
Of what exactly is that?
Minus 4 minus 2 and 6.
Plus 4 plus 2 minus 6.
Jeez. Why does it do this to me?
X plus 2 and what?
X minus 6.
I'm so done.
Okay. And so if you took these 3 and you FOILed this one, and then FOILed that, and then multiplied this one in, no, but you'll trust me, if you did all those three, it would come out to this. These are the three factors of this.
How'd you get the third thing?
This one here?
How'd you, yeah.
I just made
No,
numbers.
how would you get x cubed?
What's
I'm factoring this out.
Because you're doing x plus 4
x
times
plus
x plus 12
4
times
times,
x minus
it's x
6.
squared plus 6x plus 8 multiplied by x minus 6.
I'll only do one at a time.
X cubed plus
Okay.
6x squared plus 8x minus 6x squared minus 36x,
Oh, x.
right? Minus 48. So then you 36 plus 44 x minus 8.
I got it. Yep, I got it.
Our answer.
I got it.
Where did I miss something there?
The 8 and the
So
36.
x cubed minus 28. X
Minus 36. It's 8x minus 36x.
Here, let me see.
36.
You ended up erasing it.
Oh,
Right under the 6 where you crossed out.
this here. Oh,
no,
I see.
no, not the other one.
This is
There's-
36.
No, there's a 36 underneath it.
Right here. Oh, right here.
Yes.
Oh, I see what you're saying.
You
I erased it.
But it's a negative 36 and you added, not saying the
Okay.
negative was above it.
But this is what. So they factor
Yeah,
up to
I
that.
got it. Oh, wow. That's
Okay. So why do it? Well, the idea is
Cause.
so you can find. The idea is this whole chapter is finding the zeros. And what does the zeros tell us? When it's a zero, what does it tell us? So now you know where it goes immediately. You know what the factors are. What does all that still tell us?
That has remained.
Right. These are factors of this. What else does that tell us? Anything else?
Where x crosses.
Where it crosses the x-axis. Good. Okay. So
I got excited. I actually knew something for once.
minus
I was gonna say,
4,
I kept getting cut off.
minus 2, and 6. Okay. So these are all intercepts, x-intercepts. These numbers here are all x-intercepts. That's where it's going to cross the x-axis. Okay.
Is that where it is going across or where it
Yeah.
could cross?
It does cross.
Oh.
That's where it's going to cross. You know, looking at this, how's it going to start and end? We'll just go back to last time for a quick review. Huh?
It's this.
It's going to start just like the cubic, right?
Yeah. Cute. Back. And then in there
Oh, it's gonna be
something.
all crazy in there.
It's going to be all crazy in the middle.
Where are you here? It's gonna be all crazy.
Something like that.
That's a seven. That's cool.
All right. So what does that have to do with synthetic division? In summary, the remainder r obtained in the synthetic division of f of x by x of k provides the following information. So the remainder gives you the value of f at x equals k. Okay? So whatever that remainder is going to give you the value of x at k. Okay? Number 2, if r is 0, then you know that the x minus k is a factor of x. So any place where it's going to give you a remainder of 0, then that's going to be a factor of your original polynomial. And then, what we just discussed, if r equals 0, the point k0 is an x-intercept of the graph of f. Okay? So those are the three things that you find out from using those remainders. Okay? If the remainder is 0, it's an even factor. If it's going to be an intercept of the graph, and where there is a remainder, if you evaluate that remainder, it'll give you wherever that point will be at the remainder when you plug it in. All right. The rational zero test. Okay. If a polynomial, and that's just a long polynomial, notice it's in order from the highest degree down. What do we call this term, by the way? This a0. You'll notice there's not an x in it. There's not a variable in it. What do we call that? What part of our polynomial is that? That's our constant term.
Oh, wow, that was nice.
Right, that's a constant term. That's just a number. Okay? Has integer coefficients. Every rational zero of f has the form rational zero p over q, where p and q have no common factors other than 1. P is a factor of the constant term, and q is a factor of the leading coefficient. All right. Do I have an example on here? All right. Come up with, somebody give me a polynomial. I just want, it'll become easier, right? I'll show what these p's and q's mean. So just give me a polynomial, but give me one like this, a nice long one.
X
X
cubed
cubed
minus 7x squared plus 3x minus 8.
minus 8. Okay, good. So it can. So this works for any polynomial. So that's why I let you pick one. Okay. So this tells you that the rational zero test does this. The p is going to stand for the constant factor. So what's our constant factor?
8.
Okay.
Negative 8.
It's just 8, but you'll see. It's going to be plus or minus. Okay.
What?
You'll see. So what it wants is all the factors of 8. So what are the factors of 8? What two things can I multiply together to
2
get 8?
and 4.
Start with the easiest one.
1
With the
and
lo-
8.
1. What's the next one? Well, you're all right. So let's do 8. 1 and 8. What else? And the last one? 4. Okay, so those are all the factors of 8. Okay? That's the p function. The p is all the factors of the constant term.
Okay.
Q is the factor of the leading coefficient. What's the leading coefficient?
1.
It's just 1, right? Because there's no number.
Oh, I thought you meant.
Okay? It's just... Okay.
Now what?
So once we have that, now that gives us a bunch of numbers. So we're going to take those and we're going to put those, what numbers can those possibly make? Well, plus 1 over 1, so it can be plus 1. It can be minus 1, because you could have plus over a minus or a minus over a plus. Then do the 8s next. 8 over 1 is,
8.
and it could have been negative, so it can be negative 8, right? What's this
2.
one? And
Negative 2.
the last one?
4 negative 4.
Okay. What this rational zero test is going to tell you is, these are the possible numbers, those 8 that it gave you there. Those are the possible numbers where it can cross the x-axis, or which can be factors of the polynomial. Doesn't mean they all are, but it means these are the only possible ones. These are the only possible numbers that can cross that polynomial you gave me, Kelly, can cross the x-axis. Those are the only possibilities. So, next we can use, there's a polynomial. Next we can use synthetic division to determine which of these where it actually does cross. So what it's doing is this rational zero test is allowing you to eliminate some of the numbers. Okay? So let's put these in and see where it actually, so next you want to evaluate where it actually does cross. These are all the possibilities where this can
So
be.
we have to put them all in?
Well, this is telling you what are possible. There's more tests we're going to go through here in a second, but let's graph this. Let's graph this function that
It's
yeah.
going to be a really weird function, I'm sure.
It's not that bad.
So. You know what it is?
No, I'm
See, like,
just. Oh.
Let's graph it. That way we'll save time by not put. You could plug in all these numbers into synthetic division to come up with it, but
Are we gonna have
let's
to?
but no, let's graph it. We'll eliminate some. Minus 7x squared
What?
plus
How'd you?
plus 3x.
I went to here and I went to Zoom and then I did Zoom fit. Number 8. Or whatever.
And because you have the minus 8, it shifted us, right?
Oh, Zoom fit.
Gave us a vertical shift.
Mine's.
So that's
Oh!
gonna change your viewing window. Probably see this then.
That's so cool. the graph you gave
I made a graph.
us. Feel so
Made a
proud.
function.
Okay, do you got me yet, or you still got the whole graph?
Yeah.
Okay. So, where does it appear like that's gonna cross by looking at it? Which of those?
Zero.
Well,
We don't
like,
have
it doesn't
zero.
cross a zero. Unless you graphed it.
Is it 1?
Negative.
I'm feeling 1.
Yeah. You could. The reason is because it's so flat. It looks like it's crossing a zero there, but 1 is where it's actually on the line. And let's do it. So it's a +1. So we're saying that x plus 1. I'm sorry. X minus 1 is a factor, right? Because
Yeah.
the factor. Okay. You understand why I did the minus, right?
Yeah.
All right.
Maybe
So
8, positive 8.
so let's do it at +1 and do the synthetic division out.
Oh, what?
Do the synthetic division for the +1.
Oh, for that thingy?
Yeah.
You know what? I'm feeling it.
And it's 1 minus 7 plus 3 minus 8.
Okay, let's see if I can remember. Isn't it minus 1 from 7?
Say that again.
Is it minus 1 from 7?
You're just gonna carry the 1 down, then what are you gonna do?
Multiply 1
It's 1, which it gives you minus 6.
Oh.
6 times 1 is -6. Gives us a
3.
3.
Negative. I refuse to give up on this.
Oh, I didn't put my negative in, that's why.
Wait, it's supposed to be a negative 1?
Yeah, remember you have to do this subtraction problem. I'm sorry.
Wow, Mr. Saber.
So that would be -1, -8, which is 8, which is 5. One minus 7 plus 3 minus 8.
No, it's not in there because I made it
No, I understand.
up. Okay. Wanted to make sure.
I know they made up. I didn't make it in the book. Did I skip a term? I didn't skip a term. Okay,
I wouldn't think it would be. If it was, I would be really surprised.
That'd be pretty cool.
Let me,
I'm
hang on 1 second.
We're gonna do this. We're gonna solve Kelly's.
Let me go over quick. I want because I don't want to run out of time here, and then we'll go through the synthetic division. Descartes' rule of signs. Descartes, you all love Descartes. You studied him in geometry a little. Let f of x equals this polynomial, and a polynomial with real coefficients. So you have whatever the leading coefficient, and then all your other coefficients. What Descartes' rule of signs says is the number of positive real zeros of f is either equal to the number of variations in the sign of f of x, or less than the number by an even integer. Read me your polynomial that you gave me last time, x, that we just did. What was
What?
the polynomial you just made up on the last screen?
Oh, I don't care. X cubed minus.
X cubed minus 7x squared plus 3x minus 8. Okay. So, how many sign variations are there? That just means that we went from either a plus to a minus or a minus to a plus. So this is a plus. So we have 1, 2, 3, right? 3 sign changes, right? You got that? Okay.
Yeah.
And then, so that's saying that either, so the number of positive real zeros is either 3, the number of variations, or less than that by an even integer. So what would be less than this by an even integer?
2.
An even integer. We do even, we count by 2's, right?
Oh, 1, yeah.
So it'd be 1. Okay? So that's saying that either this thing crosses the x-axis 3 times or 1 time. That's what Descartes' sign change says. And then it says, those are the positive real zeros. And then it says the number of negative real zeros is either equal to the number of variations of the sign of negative f of x. So if this is a negative, if we're going to change x with negative x. So if I have negative x, what's this polynomial going to change to? If I substitute negative x for x.
2. No. Yeah. No.
What's
Yes. 2. No. That's not.
What? That's all right. Do you see what if I take a negative there and I cube a negative, I'm going to get a negative still.
Yeah.
All right. What about this one?
That'll be positive.
But I have a minus there.
Yeah, but it's a negative x.
What's that? Right. Negative x squared is x. It's negative x squared is just still x
Oh, so
squared.
it's going to be negative.
What about this one?
Positive.
I'm not putting a negative x in.
Y.
Why? That's what I'm doing the whole thing. I'm putting negative x's in for my x's.
Oh!
Right?
Negative. So,
Negative x minus 8, right?
so none.
So how many sign changes are there? 0. That tells me that there are no negative real zeros. In other words, there are no zero, it doesn't cross the x-axis on the negative side of the graph. Okay? So I'm going to either have 3 zeros or 1 zero on the positive side, and I'm not going to have any negative zeros.
And I think it has 1.
That tells me that if I go back, hang on. So that tells me right off with the card tool of signs, my -1, my -8, my -2, those are gone. There's no negative zeros.
So those are.
So there's either 3 or 1. So these are still possibilities to try, but it's definitely not going to be all 4. It's either going to be 3 of those or 1 of those.
That's one.
X plus
Hang
1.
on, hang on, hang on.
X plus 8, Y plus 4. That's my guess.
Now let's look at the last one real quick so that I don't
Yes.
have 5 minutes. The upper and lower bound rules. Let f of x be a polynomial. We have our polynomial. With real coefficients and a positive leading coefficient. We have a positive leading coefficient. Suppose f of x is divided by x minus c using synthetic division. That can be anything at all. It's just you're dividing it by x minus some number. We're calling it c. Okay? If c is positive, and each number in the last row of our synthetic division, our last row, where's the synthetic division problem at? This is your last row down here, your final row, you're substituting it in for, is either positive or 0, then c is an upper bound. Give me one that we did for homework. Give me one of those that you did synthetic division for.
Minus 2.
-2.
So you're divided by
Okay.
9 minus 18 minus 16 plus 32.
Okay. Was that the last row you gave me?
That
Or
was
that
the
first, that was the first row? Okay. So what that's telling
You
you,
want the last row?
not right now. Well, what was the answer? Are they all positive or
Yes.
they are all positive? Okay. So if they're all positive, that means that this number -2 is an upper bound. Okay? An upper bound means that there's no zeros after -2. -2 is the highest number you can have that it can cross the x-axis. So for that polynomial that you gave me, whatever, I don't know what it is. I guess, was it 9x cubed? 9x cubed minus 18x squared minus 16x plus 32. That polynomial can't cross the x-axis after the point -2. That's an upper bound. The lower bound is if in the last row is alternatively positive negative, a plus or minus a plus every other term, then that means it's a lower bound. That means this would be the lowest point where it could cross the x-axis. Those are all the rules. You should be able to get through the homework tonight. That's the rest of that chapter. So just the rest of those problems. Then we go through any of your questions on tomorrow. I would do the quiz before you start the homework so you don't confuse yourself.